Okay, and a good morning to everyone. We delayed just for about 1 minute to start. We were trying to get a quiz finished up here, and what we did is from yesterday, as I carried on a bit longer than I should have, we had a quiz today on the 11 properties of the real number system, and people are just finishing that up now. And so when it gets done, bring it on up. And I've returned to you the quiz from Friday, graded. And remember what we just did now is a replacement for that. So if that did not go well and you did well on the 10 or 11 properties, you could get 11 points. That's a trade-off for that. And so that gets that done. So if you are doing the properties, okay, Nancy and Bomaro, do you want to bring yours up here in the front, please? And we'll get those as soon as we can. Time's up. And Isaac also, thank you. Okay, and we'll get those up here. Appreciate that. Thank you. And hopefully that's an improvement over what you did before. Yesterday we worked on addition of signed numbers, what we call the integers. How did that go? Are there questions you have on that? Or are we needing to talk about it? Kim?
Did we need to do in the order how you were doing it on the board?
In the order I did it. I mean, as far as collecting like the... Okay, the question is if you look at it, you know what the answers are because you can go through and add and subtract in your head. I would like some documentation. So this brings up the question of the documentation that is necessary for these problems. So Kim, can you give me an example of one that I can look at, and we'll put that on the board. And then just a comment, Rita and I had a discussion yesterday about your homework, that you're supposed to have her okay at the end of the week. And I thought, since that didn't get done the way it should have been last week, I'm going to add a new wrinkle. And this is sort of adjusting as we go along to make things work better. And the adjustment is this, and it is each week we have a quiz, just like we had a review test and such that we did in 10. If you're going to get credit for your quiz, then it's going to have your books signed off or you don't get credit for the quiz. So I think one of you had it signed off last week. I'll still give you time, but that has to be signed off plus what we do this week signed off to get credit for the second and third quiz. Now the quiz today is just a makeup, but to get credit for that, you do have to have your books signed off by Rita, and that needs to be done on a weekly basis. We only had one of you do it last week. The difference between how things are going for us compared to what we did in 10 has a little bit to do with the time we have available. I realize that. And also some of the things we tried to make happen by required tutorials. You don't have that luxury on a daily basis, and you are, I'm sure, finding it a little bit difficult finding the time on campus to get everything done you're supposed to get done. But that's going to be the difference between surviving and not surviving. We go up a notch in terms of what's required, and we aren't getting the support that we had in 10 to the same degree. Now, Loretta is there in the afternoons at the 2:30 to 3:30 tutorial. So there is the usual hour for help if you want to use it. That's when you get your books signed off. That's when help is available. Now, I'm assuming that we're still doing 9 to 10, but things like today where we have a quiz where I did it as a makeup, then the thought was you'd be here about 10 minutes till so you weren't rushed. And that didn't happen today, even though we announced it yesterday. So you have to be a little bit careful about how you're managing your time. This is a rather critical issue. You have to be spending more time, I think, than you're spending. Now, the high grade in the quiz was 90. So we had one high grade at 90 with the A. We had a couple B's and C's, and we had an awful lot of papers at 50 or under. And hopefully today allowed you to replace that with at least a 60 or a 70. And then we have a quiz this Friday. What I think is missing, as I say, is just not enough time that we're spending together working on the problems. And this was the effort we're trying to make where we have more support than you would have if you were just in a regular 20. The support's there, but you have to put your time into it. Okay? And that's not happening. So it's something that I'm very concerned about. And attendance is a rather critical issue in here. And we have a few people not here today. And attendance is really something that can catch you in terms of it's non-forgiving. You can get by with it in 10. You can't get by with it in 20. You just about have to make the same commitment to 20 that you made in 10. Be here every day. Do your homework every day. And otherwise, it just doesn't happen. So with that said, are there questions? Now, Kim, can we take your question and let's see what we can do with it. Now, the idea here is that there is a way of showing some documentation. And so what I want to do is get a piece of chalk. And Kim, do you want to go and give me your problem?
On 17 or 33 meters plus negative 82 meters.
Okay.
Plus negative 64 meters.
Okay.
And I just went to the side and added the negative 182 and the negative 64.
Is that 182 or 82?
It's negative 182.
Ah, okay, 182. Okay, so you basically said that you replaced this with the sum of these two, which I would do also. You combine these two, and so that was a negative what? A 6 and a 4 and a 2. I would do the same thing. Now what I'm trying to get you to realize at this point, rather than just say negative 243, which would be the correct answer, I would still like to have you think in terms of that as a 3 plus a negative 3 plus a negative 243, because it's breaking this into these two pieces that allows you to say this is 0.
Wait, that should be 33, not instead of 3.
Thank you. I didn't catch the other 3, did I? So then this should be negative 33 here, and that will change this to a 13, correct?
Yes.
But my point being, I'd like to use the idea of an identity to say, okay, then 0 plus this is just negative 213. Now certainly you can do it without this part. The question is, are you going to be able to continually add and subtract signed numbers without any difficulty? If you can, I don't want to push this too hard. But this is typically the area where problems do occur in working with negative and positive integers.
When you put the negative 33 in the quotations, why did you do that?
Meaning the parentheses?
Yeah.
Technically, this should be also.
Yeah.
And each of these could be done to indicate to you that they are negative numbers that are being added. So this is a sign of operation. This is a sign indicating that you have a negative value, a negative integer. And so that's optional. I could have just as easily said in this step that I have 33 plus a negative 33 plus a negative 213. And what I'm wanting for you to realize is that this is using the property of the inverse. That I add these two together now because the associative property says I can add the first two or the last two. So in a sense, right here, if I get rid of this, if that's cluttering up for you, well, I'm trying to get that so it looks decent, and I get rid of this for the same reason for a moment, then you could think of, by substitution, I've taken the negative 246 and written it as negative 33 and this. Now, the associative property allows you to do what? Take this parentheses and just move it over here. And that's what I've done as I've gone from here to here, so that this part becomes the 0, and then this is what's left over here added together, and that just gives you the negative 213. When we talk about properties, and we talk about what happens in algebra, that's precisely what would be done in the first week of the algebra class. That's my concern. If you can't do what I did just here and make those properties work for you, then you've got a difficulty of what's going to happen that first week in algebra. And this is one of the few places we can really emphasize this at the moment. But what's motivating me in this is the first chapter of the algebra course in Math 70. Now, I don't know if that answers your question well enough. There are two parts. One, can you get the answer? Yeah, that's critical. Can you use the properties and make sense of them? That's also critical.
Yeah, because I'm still a little confused about when you take the negative. I mean,
This part from here to here?
Yeah.
I'm breaking up this negative part so that I have, as part of this, the inverse of 33.
Okay. I see that.
I want the inverse of 33 so I can add that and get 0. And then I don't have to worry about an absolute value, which is larger, which is smaller. It's a very straightforward process, I hope. Richie?
So you have to figure out the problem first in order to put it as negative.
Yes, to the extent I traded this in for a negative 246. That I hope's okay.
Okay, well, yeah.
Now when I get here, I want to break this negative part into two pieces. One that'll offset the 33. So I needed a negative 33. So 246 is negative 33 and 213. This forced the negative 33. And then what's left? That right here is the important part we're talking about. Michael?
So basically that's just the way to check your work.
In a way, it's checking your work. In a more important way, it is using the properties of the real number system to explain how you're getting an answer without having to use the number line, without having to use credits and debits, without having to sit there and memorize absolute value rules. It's just saying we have these 11 properties. Can we use them? And I use those to do this problem. And the answer is yes. Now, what Kim was saying, she could go from right here to the negative 213 and just get it. And I don't object to that. But are you understanding what defends that? And I've used substitution, associative property, additive identity to get my answer using the properties of the system. And that's what I'm trying to push here. We've got properties, and they allow us to make the decision we're making there. Okay. Now, I'm going to use the same argument when we get to multiplication tomorrow and talk about a negative times a positive. Okay. So it gives us a way of forcing the issue. Now, to do that, let me try to illustrate it. I'm thinking what I want to say here. Let me just try in terms of numbers in a similar fashion. Let's say I have a negative 2 times a 3 plus a negative 3. Now, I know that that should be 0. Do we agree? The argument is, this is a number added to its inverse, so this should be 0. And the 0 multiplication property says we should get 0 there. Now, that's not an identity, because the identity for addition is 0, but not for multiplication. Now, let's apply the distributive property. The negative 2 times 3, okay, and then negative 2 times negative 3. Now, at some point, I have to, before I carried out the part I want here, in a sense, I'm worried what this should be. At some point, I have to establish that a 3 times negative 2 is going to give you a negative 6. Okay? Now, that's, at the moment, assuming that we could establish that, then what does that say about this if I'm supposed to get 0 from this answer? Well, this part here has to be something, so when I add these, I get 0. So this has to be a 6 in order to get that 0. So negative 2 times negative 3 has to be that positive 6. So we get the argument that a negative number times a negative number is positive. Now, as I say, that's conditioned on what? What this means. Well, this I can work with because 3 is a multiple of negative 2. This is translated into negative 2 plus negative 2 plus negative 2. That's what that 3 means. And if you understand in addition that this has to be negative 6, then you are forced then by the properties to argue that negative 2 times negative 3 must be a positive 6. That is the argument that is used for the product of two negatives giving you a positive, using the properties of the number system. Now, another way of doing that, and this is sort of looking ahead, but it's all part of what I'm trying to answer. Why are we doing certain things? If I can look at that negative 2 times, let's say 3, and argue that's negative 6, and negative 2 times 2 is negative 4, and negative 2 times 1 is negative 2, and negative 2 times 0 is 0, you're supposed to see something going on here. Let's slide a little bit now to this side, if you would, please, Jonathan. What are you seeing? A pattern? Negative 6, negative 4, negative 2, 0. The next one should be what? No. If I take a negative 2 now times a negative 1 and think of what's happening, I've added 2 each time, so this becomes 2. So if that pattern is making sense, this suggests that a negative 2 times a negative 1 must be a what? Positive 2, so the product of two negative numbers becoming positive. That's where we are in the next section. And so you see generic kinds of statements, something like this, that if I have a negative times a negative, a positive times a positive, these will come out positive. If I have a negative times a positive or a positive times a negative, that I'll get negative. They're nice little statements that tell you what's happening, but you don't multiply two negatives together. You multiply two negative numbers together. So this is a little bit, it's useful, but it's invalid. The way we usually say something like this is if I'm going to take A times B, if A is positive and B is positive, notice greater than 0, to the right of 0, to the right of 0, then this will be to the right of 0. If A is to the left of 0, negative, and B is to the left of 0, then this will still be true. So either one of these two. Now, when is AB less than 0? The product. Well, that's when A is positive and B is negative, or when A is negative and B is positive. So we have these two here and these two here. So this gives you the general rule in terms of notation, and this gives you the other one. And that's what the next lesson's about. The next review, for those of you who've seen signed numbers before. But I'm trying to take it from just working with signed numbers to what algebra is about. And this is a general kind of statement that involves algebra. A and B are real numbers. For the moment, we're saying integers. But we can, in just a heartbeat away, say fractions. Another heartbeat, decimals, square roots, and it works. Okay? This is where I need to have you if you're going to be able to deal with the algebra and be successful. So, my concern, and Robert, I'm going to wake you up for a moment. Can you find me some other chalk over there on that board besides this piece now that is smaller than small? I mean, I'm down to something that is about 1/4 inch by something. Thank you very much. Appreciate that. There is a feeling, and this is one of the things we're talking about in terms of curriculum. And it's one of the great concerns. Student in Sarah's class yesterday basically says, I have Math 20 and got an A. I can't do any of this. This is a Math 70 now, second week. My concern is, what did that A indicate? What was demanded? Because if you come out of a Math 20 that's done well, and you get a good grade in it, then you should be able to handle what's there in a 70. This is what has to become part of your language. You can't just think in terms of numbers and avoid all the letters. Now I'm going to carry this one step further. Absolute value. You said that the absolute value of -3 is 3, correct?
Yes.
And you said the absolute value of 3 was 3. There's another way I can look at this. I can say that this is the additive inverse of -3. True? So what is the absolute value of A? Well, your first question is A positive or negative? No, it could be negative. A can represent a negative integer. A could represent a -3. The absolute value of A has to be positive, but A itself could be negative. Case in point, here's the letter A. The absolute value of that does turn out to be this. That is really minus A. I'm pausing for a moment because this is where you can go off the deep end real fast. This definition is the absolute value of A is A if A is greater than or equal to 0. It's minus A if A is less than 0. That's a question in the first exam in algebra for me. The definition of absolute value. Now playing this game of just saying it is the distance -3 is from the origin gets you through a certain level. But you need to know that if A is -3, the absolute value is actually minus A. And since A is smaller or to the left of 0, minus A is positive. Now, coming back to Robert's comment. If you look at A as a negative value, minus A is a positive number, even though it has a negative sign in front of it. One more time. If A is on the left side of the number line, minus A flips it to the other side, and so minus A is positive, because A was negative. In the pause. That's what we mean by the absolute value of A. If A is less than 0, then its absolute value is minus A. To me, that is the acid test if you're ready for Math 70. If you come in out of a Math 20, and I ask you this question, what's the absolute value of A? And you say, don't know. Well, I give you a hint. Well, let's say A is less than 0. What would have to be the absolute value of A? If you tell me at that point minus A, you give me a lot of information. Because A was less than 0, minus A is positive.
How it only becomes negative if the negative side is outside of that.
Okay, what Robert's saying is if I had this minus the absolute value of -3, that would be minus 3. I agree. And I look at the monitor if I'm in your way. Because the absolute value of -3 was 3, and the opposite of that is -3. That's not the same thing as what we're talking about. It has to be in terms of this statement right here. What can you tell me about minus a when a is less than 0? The answer is positive. If a is less than 0, minus a is greater than 0. Now I could spend the next half hour trying to convince you of that and trying to help make sure you understand it. I hope it bothers you. I hope you wake up in the middle of the night tonight saying, minus a, how can that be positive? You forget that a is not itself positive. The letter a can represent a negative number.
But only if it has a negative sign.
No.
So added
When I say a is less than 0, a is a negative number. It represents a minus 2. It represents a minus 3. The symbol represents a negative number. So when you take the additive inverse of a negative number, it must become positive. Enough.
I got you.
Okay.
That goes back to saying that quote from that guy about
Notation,
yeah.
Bertrand Russell.
Yeah.
A good notation has a subtlety and suggestiveness that at times makes it like a live teacher. Yes, Sandra.
I kind of get the bottom one. Well, at least I think I do. But the top one, I'm a little confused because isn't that greater or equal to 0?
Yes, and the absolute value is 0, 0. So we include 0 with the a when the top one. So a is non-negative. Its absolute value is just the number. But if a is to the left of 0, its absolute value is negative a, which is a positive number. No, 0 is neither positive nor negative, but its absolute value is 0. You need to explain the idea to somebody else until you have it. But this is breakpoint.
Can you do it like in numbers though, so we can like?
Okay, I did it with the number here. Here was negative 3, right? What's the absolute value of negative 3?
So 3.
Negative and negative 3. Again, if this is my number, how do I get a positive out of negative 3? By taking its inverse. So if a is my number, minus a is the inverse, and that's positive. Sandra.
So how would you figure out what A was if you had like a problem that never gave you A?
I have to take two cases. I have to give two answers since I don't know A. Good question. So if somebody says, what's the absolute value of A? And the next question you ask, is it positive or negative? I don't know. Then I'll give you two answers. If it is positive or 0, it's A. If it happens to be negative, it's minus A. And that is the definition of absolute value. That's the definition you'll see in algebra 90. My goodness, you got noisy all of a sudden. Okay, it's the definition you'll see from mathematics on. And the problem is, at certain levels, we spend too much time trying to not deal with the definition, not deal with the notation, and try to make it so it's simple. And when you do, and somebody hits then the algebra, it's over the cliff. Okay, enough with that. I'm going to go back center. Jonathan? Okay, have I messed with your head enough this morning? Very much so. I'm pleased. Okay, I want to look at something in terms of subtraction. That's what 2, 3 is about. So let me... First, we've talked about this yesterday. And so this was our rule to subtract. You change from subtraction to addition as we go to the document camp. So that's on page 114. So the idea was to change from a subtraction to an addition. That's what we're trying to do. There are a couple wrinkles here I'm a little bit bothered by. I'm really pleased with this book, but there are a few wrinkles. So Let's see what we can do here. So, for example, I have 5 minus 2 as I go to the board. That's 3. You're missing the point. I don't care that it's 3. That's a sort of no-brainer. You had that in Math 10. You probably had that before you ever came into a Math 10. It's 5 plus a negative 2 is what we are saying. We trade in a subtraction for an addition. Okay, so I take whatever was subtracted and add its inverse. Now let's check this problem. Okay, I'm taking this problem now. So what I want here is 5 plus what? The additive inverse of the additive inverse of 2. What is the additive inverse of the additive inverse of 2? 2. What do I have to add to negative 2 to get 0? That's what that's saying. One more time. The additive inverse of negative 2 asks you, what can I add to negative 2 to get 0? And the answer is 2. So this is 5 plus 2, and you get 7. Five subtract negative 2. Austrian method. What do I have to add to negative 2 to get 5?
7. Because the negative
7. 7 plus negative 2 is 5. Right? So the Austrian method, where you're adding up this way, Austrian. Now, this was using our definition of subtraction, namely, A minus B means A plus negative B. Robert, note that A plus negative B became positive. So there. Okay. Now, next step. Let me give you the rule that you use sometimes in doing this. Here's one that I think you may have heard if you ever suffered through this before. What do you do when you subtract a negative? You change the sign of this to a positive and add. So this becomes change the sign of the negative 2 to a positive and add, and you get 7. Three different approaches.
So basically, 2 negatives.
Two negatives make a positive in the sense the negative of negative 2 is 2, which is back to, slide over just a bit, the negative of a negative is a positive because it is the additive inverse of the additive inverse of 2. So if you think of a negative gives you a positive, yes. But in this 3 different approaches, okay, you're going to have to find what works for you. This one right here? Well, this is the one that actually, when I do an algebra problem with long division, and we aren't going to be in a position to do that in 20, but the minute you get into a beginning algebra, you divide an expression with letters into another expression with letters, and when you subtract, you actually change the signs and add mechanically. So I do this myself when I'm doing long division in algebra. But what should you understand out of this? And it's really this statement right here. We're back to what does A minus B mean? It's A plus negative B. So when I want to subtract, I add the additive inverse of what's called the subtrahend. In essence, I did exactly that. Jonathan, thank you. I did the same thing here, yeah. I said, I replace the minus with the plus and take the additive inverse of 2, which is negative 2. Which in this case gave you a 3. We never did finish that, but you get a 3 there, I agree. Okay?
So what if, like, you're actually trying to find what A and B were in that, like...
But see, now, you've got to be careful there. To say you're going to find what A and B are is not the point of that statement. A and B are a real number. Right now, integers. But they can be fractions, decimals, but a real number. Whatever they are, if you get an A minus B, you will call it A plus negative B.
You never try to find out what it is?
No.
Oh, okay.
Unless somebody sets up a condition. Now that's an expression there, A minus B. There's another expression. They mean the same. But if I tell you that A plus 4 is equal to 9, now I want to know what A is. And you can eyeball that and say, I hope, 5, right? I may be taking something on a leap of faith there, but you can say, A is 5. Son of a gun. We call that solving an equation. By observation. We end up stating in this part of the course that there's a related subtraction, which is the second part of this particular section of the book. We say there is a related subtraction with this. I will treat that as A equals 9 minus 4, which happens then to give you 5. That's the related subtraction. Realistically, what's happening here? I'm going to treat it differently. And this isn't just a matter of saying, you're just doing the same thing in a different way. We're talking about how you think and where it leads. And every step of the way, I'm making the same commitment I made to you in 10. What I present to you, I want to have validity 5 courses from now. What really is happening here is you add the same thing to both sides so that A is by itself. Now what could I add to a 4 to get rid of it?
You can subtract 4 from both sides.
I could subtract 4, but I could add negative 4, right?
Yeah.
So you have a choice. I can say subtract 4 from both sides. But since subtraction really is addition of an inverse, why not just add negative 4 to both sides?
And then A is left by itself.
A plus 0 is A by itself, and 9 plus negative 4 is 5. And I agree, Richie, that I could say, well, you really subtracted 4 from both sides. Yes, I could, and yes, I did. But I prefer to have you think of adding the inverse. Because, here's the next problem. Now, if I'm going to think of the rule that the text wants me to do, which is the related subtraction problem, it's saying A is 9 minus the minus 4.
I like it.
Which is, by the way, going to give you what? 9 plus 4. Because that didn't, you didn't look like you thought that was very good. So there's the inverse of negative 4, which is 4. And it looks like, God, we're making a lot of work out of this to get 13. There's a better way. And my concern, exactly as Isaac's saying, when I come up here, I don't think this should be written as a related subtraction problem. I disagree totally.
The inverse.
Yes. Well stated, because this really is coming down here, and I'm going to write it this way for the moment so you can see that it's an addition problem. But Richie's saying, add the inverse of negative 4, which is 4 to both sides, and A is 13. This is what we're going to do in an algebra class, and we aren't going to talk about a related subtraction. It is saying, okay, you'll not like this, but that's okay. If, or given, A is equal to B, and by the way, A, B, and C belong to, member of, big R, the special club. Okay, now, If A equals B, then A plus C equals B plus C. You could add the same thing to both parts of an equation, both sides, and it'll still be equal. One more time. If two things are equal, A equals B. Here is something, I'm in an awkward position because I've used A for my variable. I could have said X. So let me put it in this context. X minus 4 equals 9. Okay, there's A, that whole expression. Here's B. Two things are equal. Now, if I let C be the positive 4, so and little c equals 4, this says if I add 4 to here and 4 to here, they're supposed to still be equal.
So it'd be A plus -4.
Yeah, I'd have A plus 4 equals B plus 4 in this case. Well, B was 9, so that gave me 13. A was X minus 4, so that just gives me X. And we say, you have solved the equation. We add the same thing to both sides to get the variable by itself. We don't have a related subtraction. That's the key. Sandra, you have a look in your face.
I'm trying to figure it out because you used X, but then you have C over there, so I'm so confused with that. I'm trying to figure it out.
I said if you have two statements, A and B, they're equal, you can add the same thing to both sides. So to illustrate that, I said, what if you said X minus 4 was 9? What would you add to both sides? 4.
Right.
Because I'm calling this whole thing A now. A doesn't represent a number at this point, it's just representing an expression. So if this is bothering you, and you can see that I could add 4 to both sides and get this, that's what I want you to see. Okay?
I see that part. I just
Then good.
look at-
Stop. In the name of mathematics.
Love for mathematics.
There we go. In the name of love for mathematics. I'll go with that. Any other question there?
I like that way a lot better than doing that, all that garbage right there. But yeah, your way with adding the inverse to both sides is so much
I
better.
think I'm sort of agreeing with you, even though you called it garbage.
That's, yeah. But that is because...
But you'll learn to love this garbage.
Yeah, no, I already
Okay.
know because I
Oh, there we go.
understand it,
Okay.
and I don't understand it. But it works so much easier.
Let's do another problem.
Okay.
Okay, so let's say that you have, I'm going to use X again. X is like A. It just represents a number. But we typically use the letters X and Y and Z instead of the ABCs in algebra. So when I talk about properties, I tend to use A, B's, and C's. When I talk about equations, where I'm talking about some number, then X represents a number, unknown for the moment. But I put a condition on it. X plus 3 must be 10. Now, again, 7 works just by looking. You're going to get to the point where you can't look and see. So instead, you say, well, how do I...
Add the inverse of 3.
Okay, I can add the inverse
Yeah, add the inverse.
or subtract 3 that comes out the same, right? So you're going to do the same thing to both sides, which is adding the inverse or subtracting 3 if you wish. X plus 0, because that's understood. And that's going to give you a 7, so X is 7.
Or you can also
Go ahead.
subtract 0 from both sides.
No, once I get X plus 0, I have to understand that that is just X by the additive identity. That would be a little bit too much to subtract 0 from both sides. Yes, Soshi? Go from here to here? She's asking, can I start there and go to there and do it in my head? Yes, you can. Right now, an intermediate step because I'm trying to push an idea. So I want the intermediate step. This plus this down to here I'll accept. This is in between. You don't need that one.
Yeah, like cross-cancel.
No, cross-canceling. I know what you're saying. I know what you mean, but don't you say cross-canceling. Cross-canceling has to do with fractions, and we aren't there yet. Okay, so something sort of eliminated something else.
Yeah.
Canceled it out, but it wasn't a cross cancel.
Yeah.
Any other question there? Natalie.
Okay.
You know, and most of you, boy, have I got a question for you kind of attitude right now. That's what Sochi had, and that's what you're saying. I've got a question for you now. Okay, go ahead.
I'm totally lost.
I knew that was coming. I'm totally lost.
I get the x plus 3. Okay, so like if I was doing this one, I would just know it's 7 because I know 7 plus 3 is right.
Okay, so in your head you could do it. Now, can you do mechanically something that'll get you to there when you can't see it in your head?
And that's what I'm saying. So I'm lost when it comes to x plus 0 equals 7. How do you figure that out? What does x stand for if you don't know
X
what 7
is like A. It's any number you want. And what was the identity property in the quiz you just took?
Okay.
A plus 0 was A, correct? Did you need to know what A was? No, because A plus 0 is A. Whatever A is. So X plus 0 is X. Whatever X is. So you know you've got X there, and you've got 7 over here. So what was X? 7.
Okay, but can you tell me how did you get that 7?
By adding 10 and negative 3.
How you have the positive 3 up there?
Like whatever
Eliminate
makes one
the
side
other
of the
two.
other side. I
Whatever.
get it.
I love it when somebody else explains it.
Okay, I get it now.
Thank you, Kim.
You're just trying to get rid of whatever's next to x, so x is by itself.
Right.
Isolate X. Not getting rid of things. Isolate. It sounds like you're going to wipe them out. So I have that 3. I'm going to get rid of it. You can erase it. But you don't. You have to do it legally. Legal get rid of. Okay, you just don't throw them out the door. No. You have to add the inverse to get something legal. Michael.
Maybe you can do it with larger numbers.
So it's not so obvious?
Yeah, right.
Oh, I could. I could do something like this. Let's say you have 3x minus 5 plus 2x equals x plus 7 minus 4x.
First of all, you got to combine like terms.
Okay, my point. Richie's right. But my point is, can you eyeball that and tell me what it is? No. But what can you do? You can combine some things, getting ahead of ourselves. You can simplify it. Let's look at, this is getting ahead a little bit. But if you have 3 of those and 2 of those, that's 5 of those. 3x and 2x would be 5x. So I have a 5x minus 5. On the right side, I have 1. There's your unseen 1. And I have negative 4, so that's negative 3 of them. And I have a 7. Now, can you still eyeball it? Probably not. But I'm going to play the same game, and I'm much further ahead than I should be. Richie, what am I going to do next?
The inverse of addition to 5x.
Okay, I add. No, I want the variable on the left side. Negative 5. So 2 steps to happiness. Let's do 2 steps at a time, one at a time. Plus 5. Plus 5. So on the left, 5x. On the right, negative 3x plus 12. Now what? I don't want this here. Add its inverse. 8x equals 12. Then you divide by 8 and get x. Agreed. So x is going to be 12 over 8, and you reduce that, which is 3/2. Now, folks, we aren't there yet. We aren't supposed to be there yet. This should not be comfortable to you. That scares me that that's comfortable to you. And this wasn't. Because you wanted to eyeball this and not do the in-between. You're screwed if you try to eyeball this one because you won't get there. You've got to add the inverses to simplify to get the variable by itself. Same concept. Here you can get by without having to do anything other than eyeball. I don't think you can here. And folks, if you're looking at this and you say, no, that's good, I'll feel better. If you're here right now, then I've got a lot of gaps to fill in so you feel why you feel better here. Now,
Okay, can I give you a problem too?
you didn't get to see the gleam in her eyes. The question is, can I give a problem for you to do? You know, I picture that kind of raised eyebrow and that I've got something for you. Okay, go ahead.
Okay, I don't know if I'm going to do the numbers right. Okay, x plus 17 equals 184. I don't know if it works.
See how you just pick those numbers out of the air? That's the same thing. 184. Okay. What am I going to do now?
Have the
So you want to go minus 17 and then make the positive 17.
So you do add a
And then you want to do the minus 17.
17 to both sides.
Agreed? You shut everything off, didn't you? Because too many people were talking. Now, I don't want that 17 there. How do I get rid of it legally? Add its inverse. Add negative 17 to both sides. Okay, so what do I have here? X plus 0. What is x plus 0? No, Natalie, what's x plus 0? Did you say that x or just, there we go. Okay, with authority. Now, what is 184 plus negative 17?
I have to...
Okay, go ahead. The music is playing. Okay. What number do you get?
Yeah.
No, I don't want yeah. What number did you get? 167. You're done. Are you happy now?
Okay, so really...
Oh, no. It is. I ask you if you're happy now. It's not, oh, yeah, well, let's go on to another one.
I am. Okay, and I know you're left math, so I don't mean to, offend you when I say this. So really that 17 and 17 is just really it's unnecessary. You can just do the 17 minus 184 to get your answer. Correct? That is...
Okay, let me provide you translation to what she's saying.
Right.
I know you love math, but don't take this as an offense. This is garbage, what we did just here.
That in-between.
The in-between, for right now, you could do without. But this should tell you that you're in deep trouble if you don't understand what to do here. Love of math or not. Okay.
All right, I got it.
Good. Anybody else? Feel like speak now or forever hold your peace. Erica. Oh no. Oh no, not me. Anybody else with a question there? Let's take a look at the problems you're going to have fun doing. Okay, we are on page 116, 117, 118, and the problems that are really of interest are on page 121. So, this is for Natalie. Number 38. I had 16 plus n equals 0. Now, I love that one because if you eyeball it, you have to see negative 16 because that's the inverse of 16. Or you can do what Richie and I have been talking about, and you add negative 16 to both sides. And since 0 plus the negative 16 is negative 16, and this would be 0 now plus n, which is n. The intermediate steps are missing from there. Okay? But 38's a good problem to focus on. Of the problems we've been working on today, for the majority of our time, 31 through 42 are the ones that are being, in many respects, the most interesting. If I come down to number 12, document Cam, then you can see what's done here. You treat this as negative 20 plus what? The additive inverse, and you've got to say in your head, negative 20 plus the additive inverse of negative 30 is 30. I think you need that plus sign in front of the minus 30. Now, the fact that you get 10 there should be fairly obvious to you. The question that Jessica's asking is, if I don't put the plus and negative 30, are you wrong? No. But let's come back off there, Jonathan. The question. Two things happening here. One is getting right answers. The other is getting enough understanding that when you go into the mess we did at the end, it's clear. There's got to be a balance there. Okay, and that's what I've been trying to present as an argument today. These early portions are about technique and understanding. It's critical. Don't short yourself in this. Jonathan, as we close down before...